All right, Unit 2, Study Guide number 2. So this time we're given our quadratic in vertex form. So my vertex form is, I'm going to write it down here on the bottom, a times x minus h plus k. Okay, and again, a lot of the same stuff applies from the way that we did standard form. Okay, so first thing we look at, let's go ahead and do our first bullet point here. Does a parabola open up or down? And we look at A. If A is positive, it opens up. And if we do look at A, our A here is 1/2. It's a positive 1/2. So our parabola is going to open up. So we know we have a U-shaped parabola for this one. Okay, now to find the vertex. I'm going to go ahead and write this down here. So now the vertex of a parabola in vertex form, we can go ahead and pluck it straight out. So we look for the negative h and the k. And remember the negative h, that we take it out as opposite. So if it's a negative 4 here, our vertex is going to be positive 4, comma, and then we look at our k. Our k is negative 5. So our vertex is 4, negative 5. Okay, so remember, opposite of h, k. So I'm going to go ahead and plug my vertex at 4 and then at negative 5. So my vertex is going to be right there. And I'm going to also write it up here so we have all our data in one place. Okay, so now it's asking if the vertex is a minimum or a maximum. So we're on to this bullet point. Is it a minimum or maximum? So we know our graph's going to open up and we know where our vertex is. So our graph will open up something like this. So if we're looking at our vertex, it's going to be down here at the bottom, the lowest point. That's going to be our minimum. That's the lowest our parabola is going to be at. So for the answer there, we have a minimum. Okay, now the equation of the axis of symmetry, or the line of symmetry, remember that goes straight down the vertex. The x value of your vertex is at 4. Ooh, it's not very straight. It's not very straight either. Okay, so let's say our line is right there. So keep in mind, remember that the axis of symmetry is always going to be x equals the x value of the vertex, which here we have 4. Okay, next step is our, looking right here, it's our y-intercept. So for y-intercept, we still plug in 0. So when we rewrite our equation, 1/2 equals 0 minus 4 squared minus 5, and we simplify. 0 minus 4 is negative 4. That's squared. We have 1/2 on the outside minus 5. Negative 4 squared gives me a positive 16. Still have that 1/2 out there. So half of 16 is 8 minus 5. That gives me 3. So for my y-intercept, we plugged in 0, and we got 3. And I'm just going to transfer it here, 0, 3, and I'm going to plug it into my graph, 0, 3, and reflect it. So it's 1, 2, 3, 4 away from the axis of symmetry, 1, 2, 3, 4. That'll be my points there. Next, we find our strategic point. We're here onto the blue. So now I got to find a strategic point, because remember, I want 5 points to graph this parabola, and it looks like 1 is available, so I'm going to use 1. I'm going to keep it easy for myself. But you could choose any of these values that don't have a y value for it, or a dot on the graph. But for now, I'm going to go ahead and use 1. So for strategic point, I chose 1, so I'm going to plug it in. I have 1/2 times 1 minus 4 squared, and I have that minus 5 on the outside. And simplify. So we'll still have 1/2. 1 minus 4 is negative 3 squared minus 5. Negative 3 squared is 9, right? So you guys got to remember your PEMDAS for these. 1/2 times 9 is or 0.5 minus 5, that gives me negative 0.5. Okay, negative half. So when I plugged in 1, I got negative 0.5. And I'm going to transfer that onto my data here. 1 comma negative 0.5, and I'm going to plot it. So at 1, negative 0.5 is right there, right halfway. So now reflect it, 1, 2, 3, 1, 2, 3. It'll be right there. And you can go ahead and draw your parabola. I'm trying to keep it pretty. Okay, so now we got to start writing our intervals down. So our increasing interval. So if we're looking at our graph, and again, we read these parabolas from left to right. So when we start, we're starting with a decrease. And that's my vertex there. We're starting with a decrease. Remember that we start here, this goes on to negative infinity, this side goes on to positive infinity. So our graph is coming in from negative infinity, right? So we're starting with the decrease. I'm going to put it under the decreasing interval. We start with a negative infinity, and we're decreasing all the way to, right? So less than or equal to x, less than or equal to. And again, it's that x value of the vertex. So that's where our decrease is. So the decrease keeps going all the way to right there, where the vertex is. Now, after the vertex, so starting from that 4 here, starting from the 4, and then when we approach infinity, we have an increase, right? We can see our graph going upwards. It has a positive slope there. So from 4 all the way to infinity, we have an increase. And the last thing we're looking at is domain, and domain is going to be all possible x values. And because these go on forever, the parabola goes on forever to negative infinity and positive infinity, we can choose any number. Right, so we just notated it as negative infinity to infinity, because we can choose any x number and get a value for it. Okay, we're going to go ahead and move on to intercept form. So intercept form, remember we have a out in front times x minus p times x minus q. Okay, this one is probably the most different one, but step 1 stays the same. The first bullet, does the parabola open up or down? We look at our a value. A there is a positive 1, so we know our parabola is going to open upward. So we're going to have that U shape again. Okay, next thing we look for is our x-intercepts. And remember, our x-intercepts, we're looking at P and Q. Okay, and we've got to take the opposites. So if P is negative 3, our first x-intercept is going to be 3, 0, right? Because we take the opposites. Our Q here is a positive 1, so our other x-intercept is going to be the opposite again, which would be negative 1, 0. So those are our two x-intercepts there. So 3, 0 and negative 1, 0, right? Opposite of P, opposite of Q. And we go ahead and plot those in. So at 3 and negative 1. Next thing we do is we go ahead and find the vertex. Okay, so remember, vertex, we have the formula just like we did for standard form. Right, to find the x value, we have p plus q divided by 2. Right, and it's going to be the middle point between these two x-intercepts. So our p was, right, so we're looking at the x-intercepts, 3 plus q is negative 1 divided by 2. So 3 minus 1, or 3 plus negative 1, gives me 2 over 2. So my x value of my vertex is 1. Let me erase some of this stuff so I have some room up here. Okay, so my x value of my vertex is 1. And now I got to find my y value. And to find the y value, we simply plug it in, right, into that quadratic that we're given. So now plugging it in, we have 1 minus 3. We plug the 1 in for x times 1 plus 1. So 1 minus 3 gives me negative 2. We've got to keep this a multiplication problem. Times 2. That gives me negative 4. So at 1, negative 4 is my vertex. And I'm just going to go ahead and write it up here. And I'm going to plot it in. So 1, negative 4 is my vertex. Now the next thing I want to do after I find my vertex is the equation for the axis of symmetry. And that's still the same rule that applies to that one. It goes straight through the vertex. And I got it as close as I can. Okay, and it doesn't hurt to check to see if you have symmetry within your graph. So from one x-intercept, that's 1, 2 away from the axis of symmetry. 1, 2 away from the axis of symmetry. You have your other point there. So you do have symmetry there, so you know you're doing it correct. So our axis of symmetry was x equals, it's still the x value of the vertex, x equals 1. Okay, next we find the y-intercept. So the y-intercept, we plug in 0. Right, that remains the same as well. So 0 minus 3 times 0 plus 1. 0 minus 3 is a negative 3. 0 plus 1 is 1. Simplify that out, we get negative 3. So we plugged in 0, and we got negative 3. I'm going to plot that on my graph, 0, negative 3, and reflect it. And there's my parabola. So remember for this one here, it's that, for any of these, if you double up on a y-intercept, if you double up on a point, remember that you can't use the y-intercept, you have to go ahead and use a strategic point, which is why that's written here. So just as a reminder for you guys, because that may or may not be on the test. But for this one, we won't need a strategic point because we already got 5 points. Okay, now last thing we gotta do is label our increasing and decreasing intervals. So again, read it from left to right. Right, this is negative infinity, and then it heads to positive infinity on this side. So it's coming from negative infinity all the way to, our vertex was 1, negative 4. All the way to that 1, it is a decrease, right? We're coming down. So we're decreasing from negative infinity to 1. Okay, now after we pass our vertex and we start coming back up and we start heading towards infinity, oops, this should be just infinity. And once we start heading towards infinity, we have our increase there, right, where our graph is coming back up, it's going up. So that starts at 1 and heads all the way to infinity. And again, our domain is going to be the same exact thing. There's no context to restrict our domain, so we could choose any x value, right? And we notate that by negative infinity to positive infinity, right? That includes all numbers, all real numbers.